Hi everyone, let's look into some examples of transformations of functions, and more specifically we'll look into description of transformations. So remember that any parent function of the form y equals f of x can be transformed based on the equation y equals af kx minus d plus c. So we have talked to greater extent about the role of each and every coefficient in the previous lessons. Remember, a is for the vertical expansions or compressions, k horizontal expansions or compressions, d is the horizontal translations, and c is the vertical translations. So what we're doing in this case is we're looking into the parent function f of x equals the square root of x, and we'll apply the transformations based on the word descriptions. So if the graph moves 3 units to the right, we call this a horizontal translation, and that would be a horizontal translation of 3 to the right, which will make the value of d equal to positive 3. So we'll say that d equals 3, and f of x has changed to become f of x minus positive 3. So when you create the parent function, the transform parent function root of x, then that will change to become y equals the square root of x minus 3. So we are changing the variable x in this case. If the graph moves 6 units up, that means that it's a vertical translation, which means that the value of c is going to be positive 6. And what that means is that y equals f of x now is becoming y equals f of x plus 6. So that will change the graph of the square root function to become y equals the square root of x plus 6. Now next we have the graph moves 9 units to the left. So that's a horizontal translation, 9 left, which will make the value of d negative 9. So y equals f of x now is changing to become y equals f of x minus negative 9. And that means that we have the function f of x plus 9. So the square root function will be y equals the square root of x plus 9. Next, we have the graph moving 1 unit down. So down means that's a vertical translation. So that means that the value of c will be negative 1. So y equals f of x has become f of x minus 1. So when you write the square root function, that will become y equals square root of x minus 1. Next, the graph becomes 3 times wider. So that is stretch, and that is an expansion more specifically in the horizontal direction. So horizontal expansion. So if the graph is becoming 3 times wider, that will make the coefficient k equal to 1 over 3. So the function now has become f of 1 over 3x. So that will change the graph to become y equals the square root of 1 over 3x. Next, we have the graph becoming 5 times shorter. So 5 times shorter means that we are changing the graph in the vertical direction, and we are compressing it more specifically in vertical direction. So that means that the coefficient a is the one at work here, and the value of a is going to be 1 divided by 5 because the graph is compressed, so it's less than 1. So the function now has become f of x multiplied by 1/5. So the y values have changed to become 1/5 of the original. So the equation of the square root function will be y equals 1 over 5, and then the square root of x. Next, we have the graph becoming 6 times taller. So again, taller means that we have a vertical, this time expansion, which makes the value of a equal to 6. So the function now has become 6 times of the original function, so, or the original y values. So this square root function will become 6 times the square root of x. Next, we have the graph becoming 2 times narrower. So that's a stretch in the horizontal direction, and then when it gets narrower is a horizontal compression. So that is caused by changes in the coefficient k, and if it is 2 times narrower, that means the values of x have been sped up by a factor of 2. So it becomes twice as big based on the coefficient k equals 2. So the function now has changed to become f of 2 times x. And the equation of this square root function will be y equals the square root of 2x. Next, the equation of a function is a reflection of f of x in the y-axis. So reflection on the y-axis, that will change the variable x to a negative x. So what that means is that the coefficient k is going to be negative 1. So therefore, we're going to say that f of x has become f of negative x. So the square root function has changed to become y equals negative, or the square root of a negative x. Now, next we have the function reflected on the x-axis. So if the reflection is over the x-axis, then the y values have changed from positive to negative or vice versa. So we're going to say that the y values have become negative or opposite of what they were. So we're going to say that y would be equal to negative square root of x, because it is the y values that are switching to opposite. So negative f of x. Now, the equation of a function that is a horizontal expansion by a factor of 6. Now, we talked about this in class. We can call it horizontal expansion by a factor of 6, 6 times wider, or horizontal expansion by 1/6, meaning that the values of x are, getting 1/6 of what they should be. So, in this case, it's a horizontal expansion by a factor of 6, means that the k value is 1/6. So the function now, it will become f of 1/6x. So this parent function, so the square root function will be the square root of 1/6. Now remember that once you have written the parent function, so the square root of x, this f will disappear. The f of x disappears, okay? So again, remember, the square root of x is equivalent to f of x, right? So you don't write both the f of x and the square root in the same equation. Now, the equation of a function that is horizontal compression by a factor of 4. So horizontal compression by a factor of 4 means that the k value is exactly 4. So that will make the equation of this function change to f of 4x. So the square root function will be the square root of 4x. Now, the equation of a function that is a vertical compression by a factor of 1/3. So that's a vertical compression, which means that the coefficient a is at work, and it's going to be 1/3. So that's going to be 1/3 of f of x. So the equation will be y equals 1/3 square root of x. Function that is vertical expansion by a factor of 5. So vertical expansion by a factor of 5, a is at work, and that means the function is getting 5 times taller. So 5 f of x. So the equation of this square root function will be equal to, will be y equals 5 square root of x. Now the equation of the inverse of f of x. So the inverse, remember, is the reflection over the line y equals x. And when this type of reflection happens, x becomes y and vice versa. And the way that we denote this is by writing it as f. negative 1 of x. Now, these are very basic, simple examples of applying one transformation at a time, but it serves us to consolidate our understanding of how to create the equations of functions when a description of transformation is given. So in the next video, I will explain how these transformations are applied when we have multiple transformations in one step or in one function altogether. Thank you for learning with me, and bye for now.